Hello, protocols, packets, and programs. My love for interactive fiction harkens back to the early days of role-playing games. There were classic books like The Warlock of Firetop Mountain, which added an RPG element to the choose-your-own-adventure concept. Infocom produced computer text adventures like Zork, where you were likely to be eaten by a grue. And today we have LLMs that can produce facts that aren't even true. Which means this week we chat with Keith Hoodlet about finding successful uses for GenAI in AppSec, whether it introduces too many flaws, whether my favored fuzzing has a future, and other F words we might apply to LLMs. Find out and stay tuned for Application Security Weekly.
This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network.
It's the show to learn the latest tools and techniques to understand DevOps, applications, and the cloud. Your trusted source for the latest AppSec news. It's time for Application Security Weekly. This is episode 323, recorded March 24th, 2025. I'm your host, Mike Shima, and I'm here with Kalyani Pawar. Hello, Kalyani.
Hello. It's nice to be on an episode 323.
We got a good, yes, we'll have to come up with some good palindromes here. And listeners, Kalyani's voice is a little rough today. She's just getting over COVID, so let's be kind to her. We may,
Thank you.
we'll see what we can do. Yes, we'll accommodate you, but it's good to have you with us, Kalyani. Thank you. Kalyani, once you get over COVID, you could risk it again by going to Identiverse 2025. It's returning to Las Vegas June 3rd through 6th. Hear from over 250 expert speakers and connect with 3,000 plus identity security professionals across 4 days covering the latest identity security trends. You could also take part in hands-on workshops and explore the brand new non-human identity pavilion, which I think that means you can say hi to a toaster. Who knows? Go and find out. Register now and save 25% with code IDV25-SecurityWeekly at securityweekly.com/IDV2025. And this brings us to our guest. Keith Hoodlet is an engineering director at Trail of Bits, where he leads a world-class team of AI/ML and application security consultants. In addition to being a pioneer in AI bias bounty hunting, Keith holds both the OSCP and OSWA certifications. And of course, he was the original host of Application Security Weekly. Hello, Keith. Thank you for joining us.
Hey, Mike. And I believe they call them Cylons, not toasters. So you got to be a little bit careful when you arrive. Anyway, neither here nor there, but good to be back.
Neither here nor there, but yes. Baltar, what a great guy he was.
Yeah.
But speaking of humans collaborating with machines, Keith, you've been doing this a bit. We actually had you on several months ago talking about that AI bias bounty from the DoD, I believe. You came in number one, so congratulations on that again. And recently, I should say ever since then, you've continued to dive into more AI LLMs, and you just posted a article on your personal blog called On AI Security Reasoning and Bias. And now I'm repeating this not because you don't know this, but I'm setting this up for our listeners so that they can understand what we're about to talk about. Yeah, you wrote a thing, Keith. So let's start there. I set you up. You're a professional here. Tell us a little bit about what prompted you to think a little bit about this AI and AppSec, and there's a little bit of fuzzing in there too, which warms my heart.
Yeah. So initially earlier this year, a person that I admire greatly, Dave Eitel, formerly Immunity Inc., had written a really interesting Daily Dave post on called like the root of the root and the bud of the bud. And I think that was an E.E. Cummings poetry reference, but talking about how getting on board with large language models for security purposes is very similar to the state of the world that we're in to fuzzing back in the early 2000s, where back then for Dave's experience, everyone was doing static analysis, but he's like, nah, I'm going to do fuzzing. And he's very, very good at it. Like he made an entire career out of it. He's an exceptional, individual in the security research space, especially when it comes to fuzzing. But just some of the like ways in which Dave had talked about LLMs, at first I was sort of befuddled. I was like, something doesn't feel quite right here, but I'm not sure what it is. And so I sat on it for a few months. And I think part of what it was is my background and degree in psychology didn't really jive with some of the analogies that Dave was using. So I figured, You know what? I'm going to just like reframe this concept or these ideas of the ways that LLMs actually work in a way that feels much more accurate to reflection on how the human brain works, and making some distinctions on how LLMs function, referring back to like 3 blue, 1 brown, and some of the like LLM capabilities as we know them as statistical machines, basically, versus the way that the human brain works, which is, sort of constantly evolving and changing and in some cases atrophying, but that's why you need to practice things. So.
I'm atrophying as we speak. I can feel it happening.
Oh no!
But yes, I know. Not because of what you said. Just dealing with AppSec for so long. But part of the point, one of the tangents I did want to bring up is that InfoSec in general just loves metaphors. InfoSec, AppSec, cybersecurity is like a car, a house, blah, blah, blah. And what happens is we end up talking about the metaphor rather than the thing itself. It's sort of like my cup of coffee. Well, if my cup of coffee was half full, then it would be more like SAST. And if it was decaf, it'd be more like DAST. And like, what does this mean? Yeah, exactly. So rather than dive too deep into the analogy, which is going to be helpful to a degree, though, to inform what we're trying to get to, is let's talk about where is that LLM helpful for AppSec in particular? Because as you pointed out, Dave Aitel built up that the whole genre, if you will, of fuzzing. I'm quite a fan of it. And maybe we can start with fuzzing itself, in the sense of you're not running an AppSec team now. Kalyani has some more direct experience there currently. Would you choose, if we start to go to our tool chests, LLMs are cool. Should we pick an LLM? Should we pick a SAS? Should we pick a fuzzer? And how do we think that choice is going to change in the next 3 years, 5 years, et cetera? Just maybe LLMs are going to become smarter?
Sure. So one minor correction, I am leading an AppSec team, but it's a team of consultants, not an internal security team. So a little different than I think.
Important nuance. Thank you.
Yeah. So we're the people you call to come in and hammer on your applications, as opposed to the internal team who's trying to like prevent these things from becoming problematic and needing us in the first place.
Builders versus breakers. Yes.
Yeah. Effectively. And so one of the things that I think is really important to note about large language models, at least in their current form, like this is potentially going to change over time as we find new gadgets and ways in which large language models can be trained, but they're basically retrieval machines from the data sets that they've been trained on. And of course, you can do reinforced learning. Sometimes you can include human feedback, but ultimately the things that they are zeroing in on are statistically representative within their data set from the context that you're providing it. And so when I think of how you can apply a large language model to a security problem, I can see places where it could be successful today. I mean, you look at like what Crossbow is doing from Ugo Damore's team, or Expo is what some people call it. Versus you look at like James Wickett and Ken Johnson over at Dry Run Security and what they're doing in the static analysis space. And large language models can find you those things that are like under the 50% of the bell curve, right? The things that are going to be much more representative in the traditional application security problems. So whether you're applying it to dynamic analysis or static analysis, or helping you build, test cases or fuzzing harnesses or things of that nature, if a large language model has seen something similar before, the likelihood of it being applicable is quite high. But when you start to apply it to things that are maybe not well represented in the data set or are continuously evolving, that is where I think that we're going to continue to run into problems as, you run into companies that are right out on the tip of the spear. The next JavaScript framework from, Node.js space, or the next, static analysis tool or framework for who knows what, right? Like, it's not going to understand those things because it doesn't have any training on it, and it doesn't have enough like context to equate it back to what it does know about to actually be effective. And so that's where I think things break down.
Yeah. And sorry, it's not the 2010s anymore. So there's not like 5 new JavaScript frameworks that are going to happen by the time we end this interview. On the other hand,
it could. We have LLMs these days.
Yeah, that's true. The LLM may have written it. And to be clear, we'll get to the LLM's writing code, but I wanted to actually skip over that and focus on, thankfully, what you were just saying, like where is LLMs helping the AppSec team, whether it's the builders, the breakers side. And one of that is, you pointed out, what have the LLMs seen? So I think it's safe to say they've seen a lot of cross-site scripting. They've seen a lot of SQL injection. We've had those for decades, got a lot of great examples to train them on. But one of the questions there comes up for me is, have we seen them be better coverage, more accurate, better than our grep, or call it a fancy grep that can work on the AST. And this is where it's sort of like my question of, it's cool to use the new tool because it's the new tool versus, well, let's talk a little bit about delivering value, so to speak. And how have you seen that nuance introduced in these tool evaluations?
Yeah, that's still really problematic from a context window perspective. I think if you have a very large mono repo, for example, and you have a lot of intermingled code, and so your data flow is perhaps complex, like I could see a large language model being very successful at identifying sources or identifying sinks, so like inputs or execution or storage points. Sure. But the problem really comes down to, do you have a full data flow in which the input is not transformed such that it becomes exploitable when it reaches the storage or execution point? And I think that that's going to continue to be a problem for very large code bases when it comes to large language models. But I will say, as a total aside or sort of adjacent to this, is as a team on our end, I mean, we're using open weight models, sort of self-hosted out in a cloud, where we can actually pull in code bases with a large enough context where it helps our auditing teams very manually work through things to say like, oh, I'm brand new to this code base. Can you help me identify, the frameworks or where the types of inputs are or the libraries and how they're using them? And so like none of it is leaving our sort of centralized ecosystem of the way in which we're working, because it's an open weight model that we're hosting. And usually this is happening with like open source projects and other things that we're working on. Client code is under NDA, so we have to be very careful about how we work with that. And that includes like just manual analysis, no LLMs. But when we're looking at like an open source project, it's out there. It's actually probably in the training data set of some of these LLMs. And so we're like, yeah, we can just like throw this into, a self-hosted DeepSeek instance, for example.
Okay. Yeah.
And so start to play with it.
And that's starting to hit that assistive capabilities. Help me understand what the code is, which, okay, that feels like actually a really great use for it, because that way the human can be more informed about, oh, here's where something looks hinky, or here's where I want to go play with some logic errors or potential logic errors. And I'm using this to build up kind of the next step, where if LLMs were to become like more autonomous and even less assistive, to me, an indicator of their success would be seeing LLMs being like earning bug bounties. And then I'll even refine that a little bit, earning a bug bounty profitably, meaning the value of what they earned balanced out the amount of CPU cycles they ran. So I'm curious there, how have you seen, the assistant turn it, rather than just source to sinks, to say, oh, hey, Keith, by the way, check over here. This looks like this might be vulnerable.
Yeah, I mean, so Ugo Damore's company Crossbow has recently come out and actually talked very publicly about, I think, being like in the top 10 for a monthly leaderboard on HackerOne. I don't know if they were actually getting paid bounties on these things, or if these are like vulnerability disclosure programs. So, mile wide, inch deep type things. But anytime I've talked to, a stealth startup company and they're like, how should we test this thing? Should we build a cyber range? I'm like, no, just go throw it at the bug bounty scene. If you actually make money, you've got a product. If you don't have a product. And so the only ones that I've actually seen do that is Crossbow. And so they seem to be having some success on the dynamic analysis side. And likewise, I mean, we've seen that not in the bug bounty space, but with the AI Cyber Challenge or the AI XCC, Trail of Bits is a finalist in that. And so we've had the experience of building a cyber reasoning system that uses AI to help seed inputs to fuzzers that then help identify crashes and vulnerabilities in an application, which then allow us to actually, like, without human intervention, break down an application, determine how it's vulnerable, exploit it, and then patch it. So there is reasonable cases in which you could say, yeah, many of the world's AppSec problems are problems that an LLM has seen before, because they're not novel or brand new. They're just someone copied code from somewhere else, and it's the same problem, just different company, slightly different code base, same exploit path.
Go ahead, Kalyani.
I'm curious if, so you said LLMs have earned bug bounty. Obviously, there's a human in the loop. I'm curious if there are examples of LLMs making bounties without a human in the loop at all, or is that something Crossbow has done already?
So my understanding is that is what Crossbow is doing. I don't have like a lot of deep knowledge there. I'm not an investor. I don't have like, I happen to know Uga and some of the team there, but I don't have any vested interest in it other than I've seen some of the stuff that they've published publicly. And my understanding of their system today is that it is autonomous. Like they may say select a starting point or select an application as like a target, but then otherwise they can throw it at this thing autonomously and attack it from there. So it seems like it's heading in that direction. But again, I think going back to what I said earlier, it's going to be the 50% under the bell curve problems that it's going to catch, which is good. I mean, that's a lot of problems for many companies, but anything that's outside those 50% of under the bell curve, you're probably going to miss, which can be dangerous and risky.
Speaking of dangerous and risky, another thing to do is being to over-index on the success of LLMs by just reading the titles of research papers. So, for example, speaking a little bit to Kalyani's point, we covered in around 2023 and 2024 some research that said, oh, here's how an LLM found some very common PHP vulns, some novel vulns within PHP, except if you dug into it, you'd realize it was actually either something extremely trivial. Here is a string concatenation, which is, okay, that's fine, but I could have grepped for that. Or it was actually trained on the vulnerability and they just didn't realize it, or you have to dig in. And Keith, even in your blog post that we started to talk about, there's a couple things that you got to read to the end. So tell us a little bit about, what that aspect was.
Yeah, so the name of the paper that I actually highlighted in my blog post, it's Interactive Tools Substantially Assist LLM Agents in Finding Security Vulnerabilities. The irony about that whole research paper is on page 8, on like the top of page 8, right-hand column. They show that actually isn't the case. So again, this comes down to like the training data problem. It became really clear to me as I was reading throughout that it felt like, okay, a lot of this, the findings that it's able to produce are probably from training data style problems. But then on page 8, it confirmed it because they basically took the 2023 tests from various CTF challenges, ran it through the system, and it was able to identify a large volume of those vulnerabilities. But when they sent it through the 2024 version of, I think it was the Seesaw CTF at NYU, it was only able to solve 2 out of the 21. And so it sort of makes you think like, okay, well, first of all, were the 2 that it did identify created or generated with an LLM to begin with, which means it would have been in the training data set. So like, I don't know, I haven't dug into that, but for the remaining 19, it couldn't solve those problems because in all likelihood, they were brand new novel problems not seen in a training data set anywhere. And so therefore could not be reliably identified by the large language model. And coming back to the name, like of the paper, it like refuted itself on page 8. And I was just like, how are they? And thankfully, it seems like this hasn't been published yet or like accepted as a paper anywhere, because it's like, yeah, the whole premise gets thrown out about halfway through the paper. So
yeah, and I think I want to be clearly, listeners will possibly suspect a bit of not anti-AI bias for me, but skepticism on its utility. But that's why I want to have this conversation. And one of the things you pointed out there is that it didn't find those vulnerabilities now. Okay, good. But what if it was trained? There is still refinement. We saw, beginning of this year, DeepSeek demonstrated more efficient on one hand and different and a better training to I'm trying not to anthropomorphize it too much, but to do better on its tasks. Let's just say it that way. The same thing could be said. We could point out to, here's what SAST misses. Here's what grep misses. For example, for as much as I love grep and my regular expressions, it doesn't know the difference between a constant and a variable. It doesn't have that abstract syntax tree. So it's going to miss things. But so let me say, so if I posit that, how much do we see a ceiling of what LLMs can do versus that's what I'm kind of grasping for here. Maybe are we already at a ceiling? What help me out, Keith? My human intelligence, it can only go so far.
Training data, as can mine. I'm not a robot. At least I'm not a Cylon, as far as I know. Anyway, going back to BSG for a minute. So my feeling on this is I was reading a Nicholas Carlini paper or blog post recently, and he actually comes out and says like you should make predictions, for 2 or 3 years out, and then like see how they hold up. And I think the things that we've seen is as time goes on and as training data gets introduced to new training runs and as new versions of frontier models or open weights models come out, the performance improves. And that would be reasonably expected if you're performing against tests that existed at the time that the new training data set came through. Right. It's sort of, they've quote unquote learned in the sense that they've been provided with new data to train on. The thing that I sort of suspect, or where I plant my flag and like the things that I think LLMs won't be able to do, is the truly novel problems that are not included in the training data set that are actually like new problems. And so coming back to like earlier where say a new JavaScript framework comes out, or say a new programming language comes out and a major company starts using it, I really don't believe that a large language model is going to be able to identify novel vulnerabilities in a new framework or a new programming language that it has not been trained on before. And that's where I end up sort of planting that like prediction of the future, where I don't think we're going to get there with the way that the technology currently works and the way that the technology is currently being trained, which it feels very brute force in the methods that it's all sort of taking place with. Is there a potential that gadgets will be found to allow it to, make these sort of intuitive leaps? Possibly, right? Like there's always the potential for that. But I feel as though right now, with the way the technology is designed and intended to work, that's just not going to happen. And so that's where I think from a large language model perspective, like the limitation exists not in, hey, can it solve last year's problems because it now has today's training data set? Sure. And is that going to be a majority of your problems as like a security team for the way that your company's writing software? Also probably yes. But if you're a large, software technology development company of any kind, expecting it to find the new novel problems that are being exploited by, well-resourced threat actors is probably unreasonable for a large language model. Now, again, that could change, but.
And that's where I would start to try and pull even some nearer term examples of, I'll start with software architecture, like architecture analysis, or just even looking at protocols. I love some protocol analysis, just understanding if we look at this protocol, okay, it has a length field. Maybe that those are known problems. Is the length field, is it going to lead to an integer overflow, underrun, a data buffer explosion, something like that? That's something to look at. But what about out of order sequencing? Like I'd be very curious just to set an LLM against, call it WebSockets. There's a protocol that already exists. What could it find about bugs within a protocol like that? And the reason I'm hitting that is that's more of a conceptual understanding of a state machine. And it starts to also struggle and push the limits of what a context window it can handle for that LLM. Two other things would be looking at smart contracts. That feels like that's a very business logic example. And we just actually talked about smart contracts last episode, so it's on my mind. But it's a great place where I think humans thrive. And for me to see LLMs contributing to a useful assistance in that area would be a sign for me that, oh, this is actually LLMs being helpful. And I'm curious, have you seen that type of a logic analysis, those logic errors, in any of the work that you or your team has been doing? Has it been helpful in that, like that?
I mean, in some respects, yes, because those patterns that you'll see of just logic-related flaws, they do tend to pop out as like a, hey, you're missing something here that really does need to be included from like a case, or a switch statement, or just the way that you've written your if-else. But what we've seen from academic research on like quote unquote reasoning of large language models, for example, there's the Apple paper that I'll include for you to include in the show notes links. When you change some of the like subtle math here, like just changing numbers causes it to just fall apart. And so I sort of wonder, because you have to remember again, within a large language model, everything is represented as a token, and it doesn't necessarily have an understanding of what the token is, but it has its understanding of what the token may be related to within this four-dimensional graph that it's looking at these tokens and saying like, oh, like king is to man as queen is to woman is like close on that four-dimensional space relatively. And so I think that in many ways, just changing the logic a little bit is probably going to cause it to shake out of not being under the like 50% of the bell curve where it's going to easily identify those problems. And that's where I think, again, looking at common frameworks, looking at common patterns, looking at LLM generated code that introduces, flaws onto itself, is going to then end up being caught by LLMs because it's in the training data set and it has an understanding of where the problem is, even though it's reproduced it via maybe some vibe coding that your developers were doing to get this code out the door, right? So I get the feeling it's going to be a bit of like, cat and cat or mouse and mouse, in the sense of like LLM generates code that has problems, LLM tool identifies problems on generated code, and then human has to come in and fix it. And I saw some meme earlier today that I thought was very relevant, which is like, 2025 is going to be the year of a lot of vibe coding. 2026 is like companies are going to realize they have all these problems. And 2027 is going to be when security professionals and software developers have to come in and like manually by hand fix all the problems that were introduced by the 2025 vibe coding wave. And that feels about on par for what I feel like I'm starting to see with just personal like friends' hobby projects where the code just gets so massive that they lose all the context of like within their own human brain as to how it's supposed to work. And then suddenly things break and they don't know how, and they don't know why, because they were vibe coding. So
it's all vibes, man. It does make me want to bring in two other topics real quick, or two other aspects of this. One, hallucinations, the non-deterministic aspect of LLMs, as well as I want to sneak in some cost too. So let's start with the hallucinations, or just the non-determinisms. And in the one aspect, I'm going to go back to grep as my non-LLM version of SAST. If you run grep, it's pretty deterministic. Depending on how good of a pattern you created, it's going to create a hit potentially. I'll admit up front, possibly some false positives, but it's going to hit that every single time.
Yeah.
LLMs, on the other hand, maybe not. How much of it behaves slightly differently every time, or it's going to hallucinate on me. How much does that diminish its assistive help for like you and your team?
So that is a huge part of it. I mean, this is why we have a lot of private SemGrep rules that we've written, CodeQL rules that we've written, fuzzing things that we've done. And so like there's the human element that we've applied to programmatically solving these problems to make sure we capture as much of this as possible in the event that an LLM doesn't assist us in the way that we expect it to. And hallucinations are sort of like they're a feature, not a bug, is I think the thing that people need to first start with about this, because again, it's all just statistically relevant words used in context, or checks used in context, in this case for AppSec. And so in many ways, like that's non-deterministic because your context, like your prompt may subtly change, or the version of the model that you're relying on has changed the model weights because there's been a new training run and new data included. And so what was reliable 3 months ago may not be reliable now because suddenly, the training data has changed from underneath you. And so in that respect, I think bearing in mind that LLMs as a technology should be like understood to cause non-deterministic output is a first thing that companies need to like say, is that acceptable or not? Because in a healthcare setting, I would say that's not acceptable. And yet, here we have summarization.
That's a worrisome phrase.
Yeah. I've even seen it in just summarization, right? Summarization of conversations that are held with clients where they say it's okay to record and we use an LLM tool and then it summarizes. And I'm like, no, it's got like all this stuff wrong, which entirely changes the context for anyone that's just reading it as opposed to like,
it's much more of a shortener than a summarizer.
Yeah. And even then it's not even accurate like all of the time either. So you have to be very thoughtful. So I'd say coming back around, first and foremost, the way that like, I think most LLM technologies can become useful is you use the LLM to summarize, to write a rule, to, assess something, but you then need to apply some critical thinking of the output of the tool set and determine like, do you know something that it missed? Do you know something that it maybe flagged incorrectly? What do you know about the system itself changing from underneath you before, like to account for all of these things? and then, applying that critical thought, move it forward or not, right? Say like, yeah, we can actually use this for this problem case to solve this problem today or not. And so, go ahead.
And you were hitting again on how the using it part. So let me switch to the second part of my setup here too. If there's one thing that is deterministic about LLMs, it's that they're going to be expensive. They're going to hit you in the budget. So I have this hypothesis that I repeat perhaps every episode, who knows, that, CPU cycle for CPU cycle, dollar for CPU cycle. I think fuzzing is more effective at finding bugs. Sometimes those bugs are security bugs, but it's going to find software quality problems. If it crashes, you got to fix it. And actually, that's what Dave Vitale was very much pointing out in his post that you were reacting to. There is that aspect of LLMs helping build that corpus, helping, guide that guide that fuzzer into finding what are those good inputs. I see you nodding. I want to ask, clearly, I think that's how you were doing it. That's how you're describing the most recent cyber challenge as well. What's a cost aspect of that? Or is anybody caring about cost yet? And it's still just trying to figure out what's the value we're getting out in terms of results as opposed to the value that we're sinking in from our budget?
So there's sort of a few spaces on this. So AICC limited us, I think it was like $100 per problem set or something like that in terms of API tokens. I'd have to go back and look at the official rules. My colleague, Michael Brown, and his team in research and engineering are the ones working on that. So I may be misquoting, but I think it was a limit of $100 per like target area or some such. So anyway, that being said, setting AICC aside for a moment, the cost of at least API tokens seems to be going down pretty substantially over time. And so in some respects, I think that the cost element of some of these LLM tools are probably fairly negligible compared to, actual cost of, say, a license. And so this is where things get really interesting, though, because you look at like the best example that I know of is the software development, like IDE based LLM. So Cursor, Windsurf, there's probably a few others, GitHub Copilot, for example. And Windsurf has like their $60 per month unlimited fast API tokens usage for their pricing model, whereas Cursor is like 20 per month, at least, as of this recording or as of the last time I checked, but you only get 5,000 fast API tokens. And so I would imagine that a majority of the customers of Cursor who continue to use it on a regular basis are likely not hitting that cap. And so they're still profitable in the sense that they're like limiting you on your fast API tokens versus Windsurf may have more power users and they're sort of saying, oh yeah, at $60, like maybe they're going to hit it for like a few users, but in bulk, like in aggregate, the majority of the users aren't going to cost that much to the company. And from what we've seen, at least, as reported in news and other articles for OpenAI, for example, they, for example, did not expect as many people to use the $200 per month subscription as profusely as they have. And so they are losing money on that prospect. Whereas in the $20 per month tier or whatever, like most of those users don't use that many tokens per month. And I'm one of those users. Like I subscribe to like, Anthropic's Claude and OpenAI and like all these things so that I have a variety of tool sets, but I can tell you that I'm definitely not using $20 worth of tokens in those spaces. So to answer your question on cost, I think for a majority of companies, a majority of their customers are probably not going to be using more tokens than their subscription is actually costing, or bringing in revenue to the company. So like there's that balance. But I don't know. I mean, it could be one of those things where the scaling stops and, everyone suddenly says like, oh yeah, the price is what it is. And you're suddenly throwing much more data into it. And so now you actually really do have a massive cost. I still don't know how Salesforce justifies, was it at like a few dollars per query or something? Like to me, that feels absurd. But then again, they're also, they have a lot of data. So that it sort of makes sense that they would charge you more because you're pulling out a lot more tokens to, run the AI over. So
Speaking of like a lot of data, and now that we know that LLMs have been trained on a lot of data sets, I was curious if you had an opinion on how it's threat modeling right now. In my experience, I've usually just seen it using terms like stride without many useful insights. And there could be like lack of context that is the problem here. But I was curious if you had any insights on that end.
Our experience has been the same. Yeah. So
Okay.
I've had a few folks who do more of like some of the offerings that we have include design reviews and threat models. So we actually help companies with these applied problems, as I think you've spoken about here on Application Security Weekly for some of our blog posts on this. So Kelly Coyotes and some other members of the team here have done some really fantastic work writing that up. And yeah, by and large, what we find is that the large language models don't get us very far along the path of threat modeling. And I think that's partly because if you think of applying a threat model to, say, cloud infrastructure, just as an example, the way in which a company configures that cloud infrastructure could be very cookie cutter, in which case I would expect a large language model to be somewhat helpful in applying all of the, places where, or like load bearing tech is happening for like authentication or data flow or other things. But many companies customize, as we all know, right? And so when you're applying a threat model to a custom set of technologies configured in a very unique way to the company, yeah, I don't expect LLMs to be very performant there, at least not yet. Could they get there? Yeah, possibly, but it just would need to probably have either specialization, so like a custom model in that case, where it has every possible configuration of the however many Azure or AWS or GCP technologies are coming into play. But then also we get back to the thing that I said earlier, which is how frequently do these cloud companies introduce a new feature set inside of that space, and then suddenly companies adopt it, and it has no idea how that functionality works because it's not in the training data set. Like that itself can be a lossy process, as I'm sort of anticipating.
Yeah, and we back in episode 320, we did cover the trail of bits way of threat modeling, and trail being an acronym. I did want to pitch real quick, since I got your attention, Keith. You could have also called it BITS for building InfoSec threat scenarios. So
maybe that'll be the next one. It'll be V2.
Yeah, okay. But that was 4 words that came to mind reading that article about humans doing threat modeling. We're almost at the end of our context window for this segment, Keith. I apologize. But before we let you go, we always ask our guests to describe AppSec in 3 words. So what have you got for us?
I have 3 sets of 3 words. So going for a buffer overflow, maybe? I don't know. Anyway, the first one was perpetually evolving problems. The second one, which is I think what I'm rooting for, is the modern definition of AppSec, which is vibe coding Vikings. And then the last one is persistent, dynamic, and evolving.
Well, you are 2 evolving. 2 out of 3 were evolving. So I like this. You're definitely thinking ahead to the future, and hopefully we'll evolve to a future where there's at least no cross-site scripting. There's a couple things that we would like to see die off in the world of application classes. But Keith, thank you so much for joining us. This was a wonderful conversation. Really appreciated it. And I guess I'm repeating myself once again by saying thank you for joining us.
My pleasure as always. Thank you so much, Mike and Kalyani. Good to have a conversation with you both again.
Happy to have you here as well, Kalyani. Thank you. And thank everyone for joining us. We're going to take a quick break now and return with news of the week. Welcome back to Application Security Weekly. We just talked with Keith Hoodlet about how LLMs can be assistants to AppSec tasks, and where many tasks still need humans. I'm your human host, Mike Shima. I'm here with human Kalyani Pawar, and human Keith Hoodlet has stuck around. Hi again, Keith.
I'm back. I'm back. Hi.
You have to bump you up. What we need you to pump up is some reasons why the heck we've kept XML around. If there's every week I try to find a theme of our news articles. This theme this week is going to be some parsers, one of my favorite things, but it's also going to be XML. Like, why? But I'm going to tease that because not even XML, just basic HTML and HTML headers. Over the weekend, Next.js and the corrupt middleware, the authorizing artifact. This is an article that came out of Zero Web Security, Zero with a ZH, some bug bounty hunters, who basically demonstrated in the Next.js, you could include a header called X middleware that has 5 entries, and that 5 entries would just basically bypass all of any internal routing, potentially bypass authorization and authentication that the middleware might be handling, and take you right to that origin server. And to me, this was just one of those things like, what? Because there was a hard-coded depth of just checking to make sure there's no, infinite loop recursion. So that's why they used 5. That's the magic number. And a lot of people were scrambling to figure out, am I vulnerable? What's going on? What do I need to fix? But on the other hand, this is where I want to pull in Keith and Kalyani's ideas. The real vulnerability is if your middleware is handling authentication and authorization, and you can just bypass it with this header. I think you can kind of tell where my mind is going with this. What's your reaction if I just say, well, the middleware is handling our authentication or authorization?
Yeah, they've mistakes have been made is sort of my initial feeling on this, which is, authentication, authorization should always be done server side, and handling it in JavaScript middleware, probably close to, or, very close to the user side. It just feels wrong on so many levels. But then again, it's a JavaScript framework. I'm not surprised by that at all in some ways too. Next.js is a great framework. Don't get me wrong, but
it's React, right? Yeah.
Yeah. It's somewhere along the way, something went wrong with, we'll just check it 5 times and that's enough. The next iteration will be 6 times. And yeah, I just, in many ways, it's like, okay, at some point you have to auth them. They probably decided not to do this closer to the server side because of a speed problem, right? You want the user to have a very fluid experience, authentication or authorization wise, to services within the application. And so I see why they would do this, but at the same time, I'm like, oh, this is just a bad idea all over again.
I also want to say that, sure, middleware is not supposed to be the authentication, the auth layers, but also I wanted to talk about this aspect of defense in depth, which we often don't pay attention to. Sometimes just thinking hey, this framework is built enough in such a way that we can masquerade maybe attempts to for making it difficult for an attacker to exploit. But there could be an additional layer after the middleware too. If that gets bypassed, maybe some other checks in place. Could be something like in an API route or what have you. But yeah, that's the first thought that came in mind. That why were we just dependent on one single layer? Yeah.
Defense in depth, yeah.
Yeah, and the point there too, both what you and Keith were saying, I want to tie that into our first segment too about LLMs is where would that advice, if we talked about threat modeling or architecture analysis, I definitely fall on the more skeptical side of, would an LLM make these kind of recommendations about ensure either a very generic, do your authentication at the app layer, do it at the API endpoint, but would it be able to identify and say, you've made a mistake here, shift this, here's a route that needs more protection, here's where you missed, or here's something that has to be implemented authentication differently. And I don't know. So it is definitely a rhetorical question on my end.
I feel like an LLM from hey, what is the right practices to do is going to, at least from a natural language perspective, tell you the right practices. I think that's pretty consistent in my experience of, asking about various capabilities that I'm trying to test it for, to does it know what DevSecOps is and how to do it right? It can give you pretty good advice, generally speaking. That said, doing it in code and doing it in nuanced ways, I think that it's something to be desired at times. There was a nice article that you and I were discussing before we started recording on how AI coding tools, quote unquote, fix bugs by adding bugs, which I thought was very apropos to this problem, where it's oh yeah, would it suggest maybe possibly doing something additional to this X middleware thing? Yes, but would that be problematic? Also probably yes. So I don't know. I have mixed feelings, as you can tell.
Mixed feelings.
I feel so secure design reviews, in my opinion. I think LLMs have had good way of doing it. I feel sometimes I present it a certain way to solve a certain problem, and then it would be hey, but there is this certain feature that you can leverage in the cloud. And that is, I think, my knowledge cap that has been, my lack of context on something which I did not know existed before an LLM told me to do it. So I feel I've been happier exploring even business logic lots of times with an LLM.
You have to be careful though, because sometimes an LLM will suggest you something that does not exist.
Yes.
Also
Yes,
problematic.
I remember this one time I was having a conversation where I was like, yesterday you told me all of these 5 ways to solve the security problem. I did not discuss this with the LLM, but it confidently regurgitated that, yes, yesterday we spoke about this. And I was like, why are you lying, bro? We did not.
Your LLM gaslighting you, just what you needed. But to both of those points too, I'll link to the article. This is from Pivot to AI and linking to a research article. One of the other points about LLMs introducing bugs is they also potentially. I love the idea that they can generate test cases, unit tests, etc. But sometimes researchers were finding the LLMs were actually cheating the test cases, or to make the test case pass, they were modifying the test case to the wrong behavior rather than the code to follow the right behavior. So it's one of those
just like a
things
developer. It's very authentic to the developer experience in some cases. So.
Yes, exactly. So I will have to admit that this is that article in particular represented to me that we've actually produced LLMs that are pretty close to what humans could do already. Introducing bugs. Which is going to be a segue to another article I've got, this one from Portswigger, about SAML roulette, the hacker always wins, which if it's an article written by Portswigger, the team, that's probably true. I think we could just take that at face value. But it's about a little bit older, a week or two ago, the Ruby XML library, where there was an authorization bypass or authentication bypass. And this one was a bit more legit in the sense of you were relying on a library designed to do SAML, designed to do that user authentication, and the library failed you. Keith and Kalyani, part of what I wanted to talk about first, though, is that in GitHub's discussion of this, they were actually looking at Ruby XML way back in 2014, and they're like, it doesn't have some features we need. We're going to write our own. Roll forward a couple of years, like, you know what? This version that we wrote on our own, we've been spending a lot of money on bug bounty reports for it. Maybe we should go back to using this Ruby XML. And that's when they found, oh, wait, what's going on? So this Ruby SAML, sorry to correctly use the name of the library, had a authentication bypass because it had 2 different XML parsers. And possibly, I think Keith has already seen where this is going. And what happened is that if you have one parser would handle what's the message that's contained in this SAML, assertion. The other parser was basically, how good is that signature? So one parser says, looks like you got a good signature. The other parser says, looks like you got a message. Did we agree? And they're sort of like, well, we agreed that the whole XML looked fine. They just didn't verify that signature applied to that very specific message. And the way that the XML structure could be mucked about with, to use my favorite technical term, the parser's behavior was slightly different and they handled it in slightly different ways. And that's where everybody was spending a long weekend fixing all of their SAML interfaces. So Keith, I want to turn to you first, and just from that idea of, do we not build versus buy, because this is open source, but build our own versus fork versus just use open source? There's an aspect there. How did that hit you?
Yeah, I have a few thoughts here. So first, full disclosure, I worked for GitHub prior to joining Trail of Bits. I was a field security engineer for GitHub Advanced Security. So I say this from outside. I was not part of the actual internal security team, so I wasn't part of the decisions to use this particular library or fork it. First and foremost, this sort of feels like rolling your own crypto, right? Like it's authentication, it's SAML, so it's like, for the money you invested in forking and maintaining your fork of this or building your own version, imagine how much more useful that would have been to the broader community had they actually invested in the open source project first, right? Like that's sort of my initial thinking. And secondly, like, oh no, parser problems. It's not like we haven't seen these for the last 30, 50 years, but it just to me feels a bit like, well, yeah, XML is cursed first and foremost. And secondly, like, they probably should have invested in, I don't know, maybe paying someone like Trail of Bits to audit it before they decided to switch back. That probably could have been a good decision overall and helped everybody in the community in the process. It's not like we didn't write Ruzzy for Ruby fuzzing.
It gets a call out actually. So from the GitHub. So so
we appreciate that, but it's like, yeah, these are problems that, first, never roll your own crypto. Maybe second, never roll your own auth.
I'd say rule 0, don't use XML, but that's wishful thinking. thinking. Yeah.
Yeah, I mean, backwards compatibility is still a problem that we continue to inherit to this day. So, I don't know. I have mixed feelings. I feel like, first and foremost, the efforts made to build their own versus help maintain this open source one were probably sort of misaligned. And especially for GitHub being the home of open source, you would have thought that they would have been aligned around working on the open source project and helping. But secondly, I think that at the end of the day, I'm glad that this was found, and I'm glad that they fixed this. But I imagine, where there's smoke, there's fire, and it would probably be nice to have this assessed a little further. So who knows? Maybe it'll end up as an individual research and development project over here at Trail of Bits. I'll put it in our queue and see what happens.
We'll look forward to. That sounds fun. And the reason, thank you for that, because the reason I wanted to highlight that aspect rather than the mechanics of the specific vulnerability is that software development has human trade-offs. It has those thinking, like, why should we do this? That even if, let's pause it for a moment, that vibe code is just going to create some useful code for us. But is it going to create a useful architecture? Is it going to give us an analysis of why did I make these decisions, or these decisions are well-founded or well-grounded on a trade-off between, call it usability, or a feature set that perhaps GitHub needed, but not many others needed, or that rather than extend this particular library, write our own. And this is what leads to secure design. And that's why I wanted to harp on this. So hopefully this resonates with at least you, Keith and Kalyani, as well as our listeners for this. There's another aspect of this I wanted to pull out, which was memory safety. So let's touch on that real quick. So Ruby, pretty sure that's memory safe. And we've seen the past year, we've talked about, hey, let's rewrite everything into Rust. But this is just another great example of you can have memory safe languages doing very un-memory safe related vulnerabilities. Even though right up front, if anything is a parser, my first recommendation would be do it in Rust. Don't do it in C, because there are also other problems to do there, or that you can run in terms of just buffer overflows, integer, length fields going wrong. But just let's have one parser. But I think I've probably beaten that topic to death. Kalyani, I had another article here that is that mix of a vulnerability, honestly, in an area that I'm not as familiar with, but that really just appeals to me and that I enjoyed reading. So this is from Objective-C, SEE, called Leaking Passwords and More on macOS. So this is from Noah Gregory, who came up with a way to leak passwords out of one of the GUIs, one of the UIs on macOS. But I'm kind of skipping over that, the fun part of the exploit, because this is the type of article that takes the time to set up what is mock. Here is some, dear reader, here is some context. Here's some background on why macOS is just a little bit different than Linux and Unix flavored systems, and why it has this idea of these messages and this mock interface generator, the MIG, as opposed to Linux-based RPCs or IPCs. Interprocess, calls. And that's an area where we've seen in the browser space, IPCs need to get hardened, and there's been even process separation so that one process can be popped, but it's just the process that does HTML rendering, for example, or HTML parsing, but it doesn't handle more sensitive data like cookies or something like that. And so that's why IPCs are nice. That was a very big tangent. Coming back to this article, it is one of these things I like to highlight, and more a bit of a call out to our listeners. As you come across these types of write-ups that you learn something from, in addition to just the exploit itself, let us know. This is one of those things that I'd love to highlight and emphasize as well. So, and listeners, we're coming up to the end of our segment. We're trying to keep these down to just 60 minutes. I want to say thank you to Keith. Thank you to Kalyani for joining us. I want to thank all of you for joining us as well. Please remember to subscribe, check out the show notes, and share us on the socials. And speaking of having fun and good conversations, check out Street Rhythms by Xenon. We'll see you next time on Application Security Weekly.